Hello friends, in this video lecture, we will try to understand the basic idea behind compounding, where and why it is going to be used, along with the laws of compounding known as A law and mu law of compounding. So basically, what are the laws for the compounding? That are nothing but A law and mu law, and that are going to used for the conversation or the compression of a signal. So they are depends on the term known as the compounding. So what it means by compounding? Compounding a signal means first compress that signal and then expand that signal, and hence in a simple way, with the help of a mathematical representation, compression plus expansion is known as compounding. So this is used for non-uniform quantization to improve SNR of a weak signal. Now we all are familiar with these few terms: non-uniform quantization, SNR and weak signal. Now especially the quantization error occurs when SNR ratio is not good. What it means by SNR? This is nothing but signal to noise ratio, and we can calculate that signal to noise ratio with the help of information contained in the signal divided by interference occurs in the signal. So interference means what? Or interface means what? Noise. So interference or interface, its ratio with the information contained in the original signal will help to gives us the value of SNR. And the value of signal to noise ratio should be good for the good compression, for the good transmission of a signal. So in the non-uniform quantization, why we are going to use compounding? This is the first thing. The quantization noise, again noise means what? Disturbance. So quantization noise NQ we can calculate with the help of delta square by 12. And delta is constant for uniform quantization, and it is not suitable for the weak signal. Why it is not suitable? For example, with the help of constant delta, I cannot change the square term, I cannot change the term in the division, that is 12. So what I can change? Only the delta. If it is constant, then for strong signal, it may be okay to transmit the signal with the help of a particular quantization noise. But for the weak signal or the low amplitude signal, obviously as the signal are weak, it is not suitable to contain or to possess a high quantization noise. So if the delta is constant, we cannot modify, we cannot decrease the quantization noise for the weak signal. So what we required? We required to vary the delta, and delta is not constant for the non-uniform quantization. Hence, the compounding term is used for the non-uniform quantization, and this is the basic theory behind the compounding. The first thing is that we require to compress the signal, and again at some time we require to expand the signal. And in this particular process, there may be the generation of the quantization noise, and that we have to control completely, or that we have to reduce for the weak signal. And yes, we can do it, but for that purpose we have to use the non-uniform quantization. Why? Because delta is not constant for them, and hence if we reduce the term delta, then obviously the NQ will get reduced, and that is better for the weak signal. Now how it is possible to reduce the delta, or how it is possible to convert a uniform distribution into the non-uniform distribution? That is nothing but the block diagram of the compounding. This is the block diagram of compounding, where the input signal is applied to a compressor. Compressor means what? It will try to compress, that means reduce the size of your data. Then that will provide to uniform quantizer. Try to understand the whole process we will use for the convert the uniform quantizer into non-uniform. Why? Because we require to reduce the quantization noise for the weak signal. But here itself we are not able to do it. For that purpose, we have to first complete this all operation. So after the compression, whatever output you are getting, you have to apply it to the uniform quantizer. And after that, whatever output you are getting, you have to apply to the expander, and hence your data will get compressed and will get expanded. So this is nothing but what? Companding, and its output is nothing but the final transfer characteristic. But before that, how the compressor will work and how the expander will work, that we have to observe. So the characteristics of the compressor are nothing but this. What is this? This is the graph of input versus output. After that, what you have to draw? You have to first draw a straight line, or you can say the line is linear line. So it will contains what? The linear characteristic, the ideal characteristics. But the actual behavior of compressor is what? It is shown with the help of this line. So what we can conclude now? For the low range of a input signal, the output is going to vary rapidly up to this. These are nothing but what? Lower input. And after that, when the input are going to increase, the value of the input is increased, then output will increase very slowly. Here, the rapid increment in the output is known as amplification. Amplification of low frequency signal. Whether it is true or not? Obviously yes. Why? Because at the lower input will be in terms of what? Signals. So signal carries what? Frequency. So at the low frequency signal, the output vary rapidly. So it gets amplified. Why? Because of increment in the output. So the increment, it can be in the form of sound also. So the output is going to rapidly increase. So the amplification process is there for the low frequency signal. And for the high frequency signal, this is what? For the high frequency signal or input, the output attenuates. That means there is no any rapid growth or the change in the output for the high frequency signal. And this is what? The characteristics for the compressor. So this is the linear line which will shows us the ideal characteristics and the difference between the actual characteristic. Now we will again try to observe the characteristic of expander. That means what happens when the signals are provided to the expander. So again, this is nothing but input, this is nothing but output. Once again, this is the linear line which will shows us the ideal characteristic and the actual characteristic of expander. Now here what you can observe, for the low frequency input, output gets attenuate. That means what? Here the input, if it is having the low frequency, then output will change very slowly. Exactly opposite of that of the compressor. And for the high frequency, this is nothing but the output. So for the high frequency input, output will change rapidly. Here amplification is used for the high frequency signal, whereas here amplification is used for the low frequency signal. So that exactly opposite things are happened for the characteristics of compressor and for the characteristics of expander. Now what it means by transfer characteristic? Companding is what? Compressor plus expander characteristic. Why? Because the meaning of companding itself is, first we required to compress the signal, then we have to expand the signal. So addition of the result of both are nothing but what? Companding. So the characteristics are companding is also addition of both these output. So how that will be looks? This is nothing but the transfer characteristic of companding. So here they try to show the output coming from the compressor, what we have seen before few seconds. Here they try to show the output coming from the expander, and this is nothing but your ideal line or the linear line. Now whatever you are getting, that everything is what? Non-uniform. And thus we says that companding is used for the non-uniform. Now what you can do with the help of this output graph, or indirectly with the help of the value which we required from the output graph, we are able to vary delta, and this is our main basic aim. Why? To remove or to decrease the quantization noise for the weak signal. How we can do that? Weak signals are going to amplify in the compressor and are going to attenuate for the output at the expander. So here if you try to observe, when the input will stop, then the compressor output will start. After the compressor output will end, the expander output will be start. So like that, this is the process or the method where we are getting the multiple values at the same point for the compressor and expansion, and hence the addition of these two things are nothing but what? This is nothing but companding. And then we can use the companding to decrease the quantization noise for the weak signal, and in this way we are able to improve the signal to noise ratio. Once the SNR is get improved, then that will surely improve the quality of the transmission of our signal, and this is the basic idea behind the companding. So we can again try to illustrate it with the help of the theoretical words. They are nothing but companding. For the audio analog signals, the amplitude of weak signal is raised and the amplitude of strong signal is decreased, thereby alternating. That means what we have just seen, alternating output we can achieve with the help of what? Compressing and expanding process. The dynamic range of the signals. The technique is helpful in improving the quality of amplified voice and musical instrument sound. Companding is the process of a compression and then expansion. And in this way, this is nothing but the summary where you can use the companding and why you can use the companding. The next thing is that with the help of the companding, you can do the transmission. But again, how to calculate the companding? For that purpose, there are two laws, and they are known as the A law of companding and mu law of companding, and both are used for the transmission purpose, especially in the telephony system. Now we are familiar with the telephony system. So in some area of the world, they are using the mu law. It can be also denoted with the help of this particular symbol, mu law. So we can calculate it with the help of some output known as the V output, which is getting from mu law companding. So how we can calculate? V out is equal to V max logarithm ln natural log of 1 plus mu into Vin by V max whole divided by natural log of 1 plus mu, where V max is the maximum uncompressed analog input amplitude. This we can get with the help of the input signal itself. V in is nothing but the amplitude of the input signal at a particular instant of time. As we all know, the companding we can get the different values at the different time. So it is vary with time. And mu is the parameter used to define the amount of compression. This is not actually your output. The output coming from the mu law is nothing but what? Here V out. And V out is the compressed output amplitude in terms of the voltage. So finally, we require the voltage for the calculation. So by using such kind of calculation, in some area, the transmission can happen. Now, if you don't want to do this calculation, that means if some area or the region, they are not going to select such kind of amount of voltage for the transmission of the signal, then what they can do? They can use what? A law of compounding. So basically, what is the difference between A law and mu law? The value of the output, and depend on which they are going to select the range of the frequency for the transmission. So V out is what? V max A into V in divided by again V max whole divided by 1 plus natural log of A. And this is the first case for which V in by V max should be in between 0 to 1 by A. And the second thing is that 1 plus natural log of A V in by V max divided by 1 plus natural log of A, and here the V in by V max if it is in between 1 by A to 1. That means due to these ranges, there are two formulas for the V out, and once you are in that particular range, then you have to use what? A law compounding. So what it means by A law compounding and where it is going to use? In Europe, the ITU-T has established the A law compounding to use the approximate true logarithmic compounding. Actually, why they are going to use such kind of output? Because every output coming from the compounding will decide the range of the frequency used for the transmission. And in this particular area, they are very much familiar or they are comfortable with the output coming from this, and so that they can use that frequency range for the telephony transmission. So this is nothing but the fixed concept of the A law and mu law compounding. Why fixed? Because formulas are fixed and we just require to put up the values which we can use with the help of the graph. So if I want to compare both the laws and if I want to conclude something about them, then how I am able to do that? The first one is the dynamic range of the mu law is greater than that of the A law. So here the dynamic range of mu law is greater. Now what it means by dynamic range? It is a ratio between the quietest and the loudest sound in the signal. So this ratio will decide the dynamic range, and finally with the help of a mathematical calculation which is completely fixed because the mathematical expressions are fixed. So they conclude that the dynamic range for the mu law is greater than that of the A law. And once the dynamic range is higher or greater, then there are the chances of increment in the noise while transmission, and this is the drawback of mu law. Once the noise will get added for the transmission, indirectly the quality of signal will get affected. Why? Because distortion occurs once noise get added, and hence because of these things only the mu law is not useful as that of the A law. But still in some areas they are going to use mu law because it has some advantages also, and that we have to see. But now at least for the conclusion, what we can say, the dynamic range of the mu law is very much greater than that of the A law. Because of use of the dynamic range, one can say that the quality get affected due to the increment in the noise and due to the presence of the distortion, and hence mostly A law is suitable instead of mu law. So here at least what we have to conclude, A law is very much useful than that of mu law. The second way how we can elaborate that A law we can use everywhere in the world, but it is not possible to use mu law. Why? Because dynamic range of the A law is smaller. That means suppose for example, the dynamic range for A law is X. And we all know that for mu law, it is what? Greater, always greater. So that will be what? X plus N. So a particular area which is already having the mu law for the telephony transmission or for the transmission of signal, then it contains X plus N. this particular amount of dynamic range. This range is useful in some application, and hence mu law is also play an important role. So x plus n area, here we can again use a law also if I want to use. How I can use? Because already x is a dynamic range which is also present in a law. But suppose there is some area which is going to use only a law. That means here only x number of dynamic range is present. And if I want to convert the signal with the help of mu law, then I am not able to do that. Why? Because I am not able to increase the range, dynamic range, because the dynamic range of a law is always smaller than that of the mu law. So it is not possible to convert the signals of a one law to other law for the a law. And here it becomes possible. So in such kind of application, then mu law is more advantageous than that of the a law. It is not possible for any telephony system or for any application to use both the laws together to generate a transmission. So either you can use a law or you can use mu law for the transmission purpose. And due to the transfer characteristic of a companding, it is possible to use both the laws for a weak signal as well as for a high signal, because to a weak signal, noise is get reduced due to the quantization noise property. Indirectly, the delta we can vary with the help of the non-uniform quantization present in the companding. Now, we have to see the advantages and drawback of mu law and a law. Mu law has a larger dynamic range, as we have already discussed, than that of a law. Second, it contains the distortion with a small signal. Why it contains the distortion? Because it has the larger dynamic range. Third one, it is used in North America and Japan. So area for the transmission with the help of the telephony system is possess the mu law in the North America and Japan, while a law is used in the Europe side. Fourth one is a law takes precedence over mu law with international calls. And fifth one, both are used to improve the process of digitization. Means both are used to modify the input signals. Why I am talking about the modification of signals? Because every signal, when it will come for any law, whether it will come for the a law or mu law, it has to go from the process of the companding. And we all know that in the process of the companding, first the compression of an input signal will take place and then expansion of the input signal will take place. In this way, signal will get modified in two forms. One in the form of compression and expansion, and secondly in the form of uniform quantization to non-uniform quantization to improve the SNR ratio. And hence both the laws, both means what? Mu law and a law. These both the laws are used to improve the digitization of the input signal with the help of modification of the signal. Now, we have discussed this particular point that a law is much more useful than that of the a law, as it contains the lower dynamic range, and because of that it having the lower distortion. Still, whenever we require the large dynamic range, then we have to go for the mu law, and this law is used in the North America and Japan. Now, a law takes the precedence over the mu law with the international calls. Means what? We can communicate with the two different areas. Nowadays also we are going to communicate with North area and Japan, and they can communicate with Europe and vice versa. Why? Because a law takes the precedence over the mu law with the international calls. That means the dynamic range of the mu law itself contains the dynamic range of the a law. And so that it is possible to do the conversation with the help of a law, which is better than that of the mu law. Now, both the system cannot possess the two laws together. That means we are not able to do the combination of the two laws for the transmission of a single signal. Both areas, they can work on the similar laws. Both areas can work on the different laws, but not a single area is able to take the combination of the two laws to make a communication. So we have to use the individual laws which we achieve with the help of the process of the compounding. So this is all about what it means by compounding, why it is useful. What it means by compounding? Compounding is nothing but the compression plus expansion of the input signal. Why it is useful? It is useful to improve the SNR by reducing the quantization noise for the weak signal. How we can do it? We can use the non-uniform quantization. Why? Because there we can change the value of delta, which is used to reduce the quantization noise. This is the basic idea behind that. And finally, we are able to convert the uniform into the non-uniform quantization with the help of the transfer characteristic of the compounding process, and due to which we are able to achieve the improvement in the signal to noise ratio. These signals we can use for the transmission with the help of two different type of laws known as the mu law and A law, where mu law is useful when we require the higher dynamic range, but it has a drawback of the distortion. And A law is useful where we require a lower dynamic range or the lower dynamic ratio. And both are used for improvement in the digitization with the help of improvement in the modification of the input signal. So this is all about the compounding and its laws. Thank you so much for watching this video. Stay tuned with Ekeeda and subscribe Ekeeda.